Okay, let's continue with the relative frequency. So this one is frequency distributions and graphs. Okay, the second one is the relative frequency graph. So what is a relative frequency graph? So relative frequency graph, if proportions are used instead of frequencies, the graphs are called relative frequency. So relative frequency graph are used when the proportion of data values that falls into a given class is more important than the actual number of data value that fall into that class. So you can see the difference when we are having the histogram, frequency polygons, and OGIF. For frequency distribution and graphs, we use only the frequency here. Y-axis we use frequency, and OGIF cumulative frequency. But for the relative frequency graph, we're gonna use for the x-axis, for the y-axis relative frequency. Here is relative frequency, and for OGIF cumulative relative frequency. So you must remember this one is x, y-axis. This one is also x, y-axis for x and y-axis. Okay, let's take a look on one example. Construct a histogram, frequency, polygon, and OGIF using relative frequency for the distribution of the miles that 20 randomly selected runners ran during a given week. So we have the class boundaries here, we have the frequency here. So how to find out the relative frequency? So relative frequency, you must total up all the frequency first. So the total of the frequency is 20. So to find out the relative frequency, you must divide 1 over 20. You will get 0.05. 2 over 20, 0.10. 3 over 20, 5 over 20, until 2 over 20. So once you get the relative frequency, try to check, is it true the total or the relative frequency is 1? So once the total, you will get 1, so meaning that your relative frequency is true. So we're going to use this relative frequency to draw histograms, frequency polygons, and OGIF. So the first one is histogram. So histogram, for if we are using the relative frequency for the y-axis. So for the class boundary starting from 5.5 until 10.5, so 5.5 until 10.5 is 0.05. So 0.05 here. And the next one is 0.10. So 0.10 here. And then the third one is 0.15. 0.15. Okay, until the rest. Okay, how about the frequency polygons? So frequency polygons, we use the relative frequency 2 for the y-axis, and then we use the class midpoint for the x-axis. So when you draw your frequency polygons, you will get, okay, class midpoint 8, 0.05, 8, 0.05, 13, 0.10, 13, 0.10. Okay, and then the last one is for OGIF. So OGIF, we use the upper class boundaries and cumulative relative frequency. So to find out how to calculate the cumulative relative frequency, you just total up all the cumulative relative frequency. Okay, once you total up, you will get the last one is 1 here. So your OGIF turn to be like this. Okay. Okay, apart from histogram, frequency polygons, and OGIF, we also have other shape of distribution. This one is, we call it as a bell shape, uniform, J shape, reverse shape. And then we have right skew, left skew, bimodal U shape. Okay, for the charts, okay, this one is, we call it as a bar graph. Okay, and then Pareto chart. So Pareto chart starting from higher until lower. Pareto chart. And then we have time series graph. we have the pie graph. Okay, so for the last one is stem and leaf plot. Okay, so for the stem and leaf plot, the concept like this, the concept is the data value as a stem and part of the data value as a leaf. Okay, let's take a look on one example. So this example, at an outpatient tasting center, the number of cardiograms performed each day for 20 days is shown. Construct a stem and leaf plot for the data. So we have this data. Okay. So the first one is, you see, 2. So if 2, you need to put 0 in front. And then we have 1 here, 13. Okay, so 0, 2, put 2 here. And then we have 1, 13, 3 put here. And then 14, 4 put here. And then the next one is 20, 0. After 20, 23. Where is 23? 3. And then 5. 5. Okay. Next one is 3. 3, 1. 1. 2. And then 2 again. 2 again. Another 2? Yes. And then 3. And then 6. Okay, 4. 4. 3. 4, 4. 4, 4. And then 5. Next is 5. 2. 1. Oh, 1 here. Sorry, 1, 2. And then the last one is 7. Okay, so you have 0, 4, and 5. Okay, this is the stem and leaf plot.